Okay, welcome to Lesson 3, Continental Drift. So we talked about the idea that the continents moved, and today is all about the evidence that we have collected over the years to prove that the continents are moving. Okay, so go ahead and set up your notebook with your title. Remember, I always say this, but remember you can pause your video whenever you need to write so that you can go at your own pace. Our challenge question for today is, what is the evidence that continents have moved? We know that to be a fact now. The one key vocabulary is continental drift, and that is the idea that the continents were once a giant landmass that broke into pieces and slowly drifted away from each other. So last time we talked about what Pangea was, and you wrote that down, but I want you today to record the actual definition of continental drift. Okay, when you're ready, you can go ahead and move on. This is Alfred Wegener, and we've learned a little bit about him so far. But in 1915, a German scientist named Alfred Wegener put together several kinds of evidence, including the locations of fossils and rock layers on different continents, to come up with a new idea about the history of the continents. His idea was that the continents were once joined together to form a single large continent called Pangea. Over geological time, Pangea split apart and parts of it moved away to form today's continents. Today, this idea is called continental drift. Drift refers to the idea that the continents slowly moved away from each other or drifted apart. In this activity, you will examine more evidence for this movement of continents. Now, as you can imagine, back in the early 1900s, when Alfred Wegener suggested that the continents moved, people thought that he was crazy. There was no way for people of that time to comprehend that something so large as a continent was actually moving around. And people joked and said, the continents aren't bobbing on the ocean like ice cubes. And they're right, they're not, but they are in fact moving. So Wegener was onto something. So we're going to take a little look at some of the evidence that Wegener collected and some of the evidence that came after him. Okay, so in 1858, scientists found fossils of the Glossopteris plant found in southern Africa, South America, Australia, and Antarctica, and India. So the Glossopteris was the same plant that they found in Antarctica. So here it is here. That's what we saw in our puzzle pieces. But we also found it in India, Africa, South America, and Australia. It does not make sense that fern plants traveled across all of those ocean spaces, but it makes more sense that they were once connected and the seeds were able to be transferred, and that's why we don't see them anymore. So that was one piece of evidence that Wegener looked at. He read that, and that kind of got his brain thinking. He also looked at ice scrapings. So on this picture, you can see the arrows pointing to the direction that he saw scrapes in the rocks. And he knew those scrapes were made by ice. And ice, if you've ever fallen on the ice, it's really hard and abrasive, and it's able to put these big grooves in the rocks. So if you matched up the direction of those scrapings, it helped to explain why places with warm climates today could have had cold climates in the past. And it also proposed the formation of that single large ice sheet that would have covered Pangea and then left its scrapes as Pangea broke apart. And the directions of the scrapings match the directions that the continents are in today. So Wegener used the ice sheet as good evidence for continental drift. Okay. He also observed that a mountain range in South America, in Argentina, lined up with an ancient African mountain range in South Africa. And if you took those two and put them together, they lined up perfectly. The layers were the same depth of the layers, same fossils in the layers, and that doesn't really make a whole lot of sense unless it suggests that those were made at the same time and they were once a part of a really big landmass. So this, and it also, if you look at this edge right here, doesn't it look like it kind of fits right into the crook there of Africa? So it also just looks like it fits together really, really well. Okay, so Alfred Wegener in 1915 wrote his book, and it was called The Origin of Continents and Oceans, and it explained his idea of continental drift. And you could probably actually find that in the library if you looked when we can go back to the library. But his book highlighted four major pieces of evidence. He said the continents look like they fit together. The fossils match in different places. Rocks and the rock layers and the mountains match. And then he looked at the climate, what's called paleoclimate data, and the fact that, Antarctica was warm at one time and different places have evidence of different climates. Unfortunately, no one took him seriously, and he was kind of a joke in the scientific community, and no one could just wrap their brain around the fact that the continents moved. Unfortunately, Wegener was never able to prove what was actually the force that was causing the continents to move, and since he couldn't do that, no one really bought into his theory. And it's kind of a sad story. He died in 1930. He was on an expedition in Greenland in the North Pole, and he got caught in a blizzard condition, and he was frozen in the ice, and he died, and he's still there today. It's too dangerous to go in and get him out. So he was buried in the ice, and he stayed there, and he never got to see his theory accepted, and it didn't really even become accepted until the 1960s. So it took a little bit of time. In 1927, there was a geologist, Alexandre Dutoit. He was French, and he looked at rock layers on the western coast of Africa, and he found those identical sequence of rock layers in South America. So that kind of goes along with what Wegener saw. And then in 1965, in the 60s, our computer software really took off and computer capabilities. And so there was a geologist, his name was Edward Bullard, and he used computers to match the coasts of South America and Africa. And he found, do you see these dark layers? Those are actually underneath the ocean. So what he found is if they took a picture of the continents and they could use sonar and ways to map the ground underneath the water, what he found out was that not only does the edges of the coastlines fit, but underneath it's really close. And so that showed how precisely two of the continents could have once been attached. Because otherwise, why would they fit so well? It was just kind of connecting the dots. But the really key piece of evidence, the one that really sealed the deal and allowed us to prove that the continents were moving, came in the 1980s. So in the 1980s, we started to put satellites up into space, and we used them for radios, and your phones use them for GPS, and the signals from if you've ever used the map function in your phone or in your car, if your parents have a navigation system, that device sends a signal to the tower, and the tower sends a signal to one of these satellites that are up in space. And that satellite communicates where you are, and it can communicate how fast you're moving, how long it's going to take you to get to certain places if you go certain speeds. That is all done by satellites and lasers. So in the 1980s, we put these stations on the continents that connected with the satellites. And what we were able to prove is that the continents are moving. We can give you their speed. We can tell you what direction they're moving. From in space, we can see that in the big picture. So on average, continents move about 2 centimeters per year. Sometimes it's a little less, sometimes it's more. But on average, if you take all of the plates and look at them, we're looking at about 2 centimeters per year. So if the continents are moving now, we can assume that they would have moved in the past. And, a centimeter here or there, or 2 centimeters here or there is not a big deal. But when you're talking about 200 million years, that's 400 million centimeters, which ends up being in thousands of kilometers. Now you're talking about continents that are able to move across the ocean. They just do so really, really slowly. Okay, so this satellite data and GPS, really, guys, is one of those things where you can just look at it and you can watch, in time how far the continents are moving. And Alfred Wegener would have loved to have seen that proven. Okay. I found this cool picture. I thought it was cool of other types of fossil evidence. And you can see that they found the Signicanthus that was in our puzzle pieces across South America and Africa. This is the Mesosaurus. He was also in the puzzle piece. There's your Glossopteris, the fern that stretched through all of those continents. And then the Listosaurus was another type of Triassic dinosaur that lived in Africa, India, and Antarctica. And again, solidifying the fact that Antarctica was probably warmer at one time. Okay, but I just really thought that was a nice visual of where those fossils had been found. Okay, I'm not sure what you took notes on. I'm not going to dictate what you write for that lesson. If you want to jot some notes down, you can. But when you are done here watching this video, I do have a short video for you to do. It is called Continental Drift. So I want you to watch it. And then when you're done watching it, I want you to go in and look in your classwork feed for the lesson 3 exit ticket. And I want you to complete that. And it's going to be a couple points and I'll put it in the grade book. If you have any questions or you're confused or you're interested and you want to know more about something, shoot me an email and we can chat about it. Or if you're not sure any of the questions, you know that I'm always here and I try to get back to you pretty quickly. So let me know if you need anything and I will look forward to doing lesson 4 with you tomorrow. Okay? Have a good day, guys. I'll talk to you soon. Bye.